Alright guys, welcome back. I'm here to do another video, and today I'm bringing a physics question to you guys. Today I had to work a physics problem for one of my friends that I teach with. I had to work it not really for them, but for their uh, son or daughter that is in college. I didn't ask if it was son or daughter because she's got both of them in college. She just asked me if I would work this problem. And then I realized, wow, it's been a long time since I've actually added vectors. So I started thinking, well, maybe someone else may be struggling with this because I really had to sit down and think about it for just a minute since it's been so long. So let's go ahead and get started. All right. I have a version of the problem up here. The other one was probably a little bit more wordy and probably a little bit more exact for some people's liking, but basically, this is what they asked me to do. The problem asked me to basically take 20 kilometers going east and add to that the 10 kilometers going north of east. And usually, when they mean north of east, they're talking about a 45-degree angle that's going exactly between north and east, halfway and halfway, halfway up and halfway to your right. So let's go ahead and start. All right. The way that I was taught to do these in college is you start with the longest vector first. Now, I always try to draw or sketch this out, maybe not always to scale. So I got a sheet of graph paper here, and I'm going to rough it up a little bit, so to speak. Just try to sketch it, draw it. That way I have a good idea of what I'm looking at. Okay. Now, what's nice about using, say, graph paper is you can use the grid as a form of measurement. If you don't have graph paper, then you can use regular ruled paper. You'll just have to use a ruler to pick your scale. So basically what I'll do is I'll pick a point on the graph somewhere. So let me pick my paintbrush. All right, there we go. And I'm going to pick a point. Let's just say I want to pick this one. Why am I picking this one? I really don't have a particular reason why I'm just picking it there, okay? So I made my dot a little bit bigger so y'all can see this. So I'm going to put a point here. Now this is where I'm going to start. Now if you're wondering why I'm starting all the way over there instead of somewhere over here, is I'm going ahead and looking at which direction they're making me go. They're making me go east, and then they're going to make me go north, which is up, and then they're going to make me go. Then they're going to have me to go east again, which is to the right as well. So I'm starting as far left on the paper as I can. Now, like I said, you don't have to do it this way, but I always like doing it this way, so that's what I'm doing. All right, so let's start with the longest one first. It says, let's go 20 kilometers east. So we got to come up with some scale that's 20 kilometers. All right, so basically what I'm going to do is I'm going to count each tick mark here as multiples of 2. So here's 2. After I move one time, here's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It looks like this right here is my mark, okay? So I'm going to put a mark there. Now let's check that, make sure that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, that's 10 moves. So once again, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So yes, there we go. So now we need to draw a straight line to that. Now, if a lot of you are like me and you have problems drawing straight lines, then use a straight edge. Since this isn't real life, this is on, I shouldn't say real life. So, since I'm not doing this in person, I'm just going to kind of cheat and draw a little box here and connect my two dots. That way it's kind of like I'm using a marker. So, at least I was hoping I could do that. I probably can't do that on here. Oh, I'm going to have to draw it by hand. All right, so you get to see how nervous I am as I draw this straight line. Yeah, straight is definitely not happening. But this is about as straight as I can get it. All right, I'll try that again. Sorry, guys. I'm just not great at drawing straight lines. Even in class, I'm not great at drawing straight lines. I need a ruler. All right, there we go. So what you do is after you draw this, you can put an arrowhead on it if you want to. Now, it might be wise if you're drawing this, maybe not to make your arrow so thick like I have, okay? Because the better you can make your dots, meaning the smaller that they are, actually the more accurate they'll be because you won't be throwing yourself off as much, okay? So like if you can stand it, if you can make your dots small like this, like there's my dot, that's great. I'm just hoping that y'all can see my dot when I do that. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So one more time. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yep. All right. So once again, just draw this straight line here. Do the best we can. Okay. And the important thing is, at the end of this vector, is put a straight line on it. Put an arrowhead. All right. Now, it's always a good idea to go ahead and label your vector. So we know that this is 20 kilometers east. And I know we have the arrow drawn pointing east, and that's fine. But, some people are really picky, meaning some teachers. So, all right. The next thing that we need to do is we need to go 10 kilometers north of east. Now that's a little bit harder to do, but basically what you're doing is we're trying to go 10 kilometers. Now this is hard for me to do, but I'm going to do my best. We're going to try to go 10 kilometers this way. And unfortunately, I don't have a straight edge, so I'm going to have to guesstimate 2, 4, 6, 8, let's say maybe 10 right here. All right, so this measurement here, now once again, this is not to scale. This is just for eyeballing purposes, just so we can get it set up. This diagonal is 10 kilometers north of east. Now, they're wanting us to add these two together. And remember, when you add vectors, you put them head to tail, meaning once you get through drawing your first vector, you kind of need to put a dot on the arrowhead, draw the second one there. So it's kind of like you're starting from scratch here, like you're drawing from another point of origin. Now, ideally, we need to just measure from here all the way over to here. That's what we need. And we need to find this this number for kilometers and this direction, this angle measurement. We need that angle measurement there, okay? That's theta. Now, I'm going to try my best to explain to you how to do this, okay? All right, vectors, okay? Vectors have components, and what that means is they have parts, okay? All vectors have x components and y components, okay? Now, what that means is they have x direction and y direction associated with them, okay? So let's look at the first direction, which is 20 kilometers. Now, when we see the 20 kilometers, it says it's going east. All right, now if you think about eastward direction, that's going to our right, and that's basically staying on a horizontal. So this is known as a horizontal component, which means an x component, okay? So our x component, the first one that we have is this 20 kilometers. Now, we just cannot just say that 20 is the answer, because a component has to have an angle associated with it. So what we have here then is we have 20 kilometers, and then we need to assign an angle to it. Well, since it's going totally straight horizontally, then we know that degree is 0, because going to the right is 0, okay? So, which means east. Now, since we're talking about an x component, that's known as the cosine. So basically, we're going to have to say that this is going to be 20 kilometers for a cosine of 0 degrees. Now, we need to enter this into the calculator, but this looks kind of weird. So what we'll do is we'll enter it in this way in the calculator. 20 cosine 0 degrees. All right, so let's do that, okay? All right, let's take our handy dandy cheatulator and let's punch that in. All right, we've got 20. Well, you on your calculator, make sure in your mode that you're in the degree mode. Okay, notice here by default we're in the radian mode. I'm going to move this over to degree. Okay, now once you're in the degree mode, let's punch this in. 20 cosine 0. All right, enter. Wow, we get 20. So we know that this is 20. All right, so we now know that this is 20 kilometers. That's great for our x component. Now, let's look at this same measurement of kilometers for this direction, this vector, this 20 kilometers east. Let's also look at it as if it were a y component. Now, y components run upward and downward, okay? They run in the vertical direction, okay? X component, y component. Let's do this now. Now, what that means is you take the same vector that you had, which is 20 kilometers east. Now, since it is east, remember that that degree is 0. So what we're going to do, instead of using cosine again, for the y component, we're going to use sine. Now, what is the degree that we're using? Well, the degree that we're using, once again, is 0. And the reason why we're using 0 degrees is that's the degree angle for east. Okay, if you're having trouble with that, it's basically this. If you were looking at a cross, okay, a Cartesian plane, an XY axis, all right, and when you label this, just like on a barn, you have east, you have north, you have west, and you have south. East is 0 degrees. North would be 90, west would be 180, south would be 270, and back around at 360. All right, but we're going to use not 360 but 0 here for east. All right, so now we're going to punch this in for a y component for the 20 kilometers. Now you're probably saying, but I'm going east. I'm not displacing myself vertically. Well, let's prove that with the math. Okay, let's grab the calculator and punch that in. 20 sine 0. Enter. Now if you look, we get 0. Now here's what's neat. Now, all of my professors never really try to break it down and explain it this simple, but here it is. If you have a vector, all that you have to do is once you draw this vector out and you're trying to add them up and you've put them head to tail, head to tail, head to tail, all you have to do is, no matter what the vector is, use cosine on it for the angle, use sine on it with the angle, and separate them, and then add up all your x's, and that's your answer for x. Add up all your answers for y, and that's all your answers for y. Once they told me that, I was like, wow, that makes so much more sense. Well, I wish they told it to me. Actually, I just sat there, and it was like, ha ha. I mean, they were saying it, but it was kind of like Charlie Brown, wah, 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 wah. But, I mean, that's what happened. All right, so we managed to do this for one of our vectors. Now, if you remember, we've got one more vector, this 10 kilometers going northeast. Let's do the x component for that. So what we'll have here then is we'll have 10 kilometers, and we'll use the cosine again because we're doing the x component. 20 cosine for, now, northeast is a 45 degree angle, so we'll use 45 here because it's north of east. So let's punch that into the handy dandy cheatulator. Now when we do this, let's see what we get. Okay, we have, once again, this was 20. No, it's 10, my bad. 10. All right, let me move the calculator over so we can see this. All right, so we've got 10. So here we go. 10 cosine 45. Now let's close that up. Enter. Now if you notice, we get 7.067. So let's write that down. So that's 7.07. 7.07 kilometers. Now that's how much x we have. Now, if you're wondering, what does this even mean right here, this 7.07? Well, let's look at this vector. If you look at this vector, you can see if we were to draw this out and make a right triangle, you can see that we actually have a displacement right here. So from the head of this arrow, it's been moved this much in the x direction. This is how much it's been displaced. So we're calculating that displacement by running the cosine, and for the vertical displacement, running the sine on that same vector. Now remember, you can always do it this way if you draw your vectors head to tail. Okay? Alright, so with that being said, there's that. Now, the total amount of all our x's, now some will write this differently, but we'll just say for all of x. So what you can do is you can write a sum sign, and you can put an x here. That's not necessary. Now, if you're wondering, that's a sum sign? Yeah, all that a sum sign is like a W or an M turned sideways, and you just put an X, okay? So the sum of all the x's is these two added up. Now, that's 27.07 kilometers. Now, one thing that we have not done is we have not figured up the y component yet. We're halfway through. All right, now let's come over here and do this. Now, on this one, we have 10 kilometers. Now, this time we're doing the y component. We're trying to find out how much we're displaced right here. So we have 10 kilometers. Then it's going to be, guess what? Sine. You're right. Sine of, what's the degree? Well, they said it was north of east, correct? All right. Since they said it's north of east, then we're going to use the 45-degree angle here. All right. Now, when we do this, ironically, we're going to get the same number again. That's just the way the sine and the cosine work on 45. All right. So watch this. It's kind of neat. So it's 10 sine. Now, this doesn't always happen, but it happens on 45. Enter. Notice we get the same number again. So we get 7 point, and I'm rounding these, 7.07. All right, so the sum of all of our y's equals 7.07 kilometers. Now, oh, that's kind of misleading there. All right. Now, a lot of you are probably thinking, well, what is the purpose of doing this? I've already got the drawing over here. You do, and that's correct. But getting the sums of all of our x components and getting all the sums of our y components allows us to draw one nice triangle. So basically, we get to redraw this triangle, okay? So when we redraw the triangle, we can simply draw it like this. Well, that was definitely not straight, was it? All right. Now, this is not to scale, okay? So please don't hate me too much, okay? So here is our nice triangle. And yes, it allows us to treat it like a nice right triangle. And we can label our x as 27.07 kilometers. And we can label this side as 7.07 kilometers. And all that we're going to be left with is trying to find this diagonal and this angle. That's the whole purpose of summing up all your x components and summing up all your y components, so we can draw one nice, pretty triangle, and we can calculate its diagonal and its angle. Okay. Now, to calculate this diagonal, this hypotenuse for this brand new right triangle, we're going to need the Pythagorean theorem. A squared plus b squared equals c squared, meaning two legs that are being squared will equal the square of the hypotenuse, okay, the diagonal. All right, sorry I was blanking out there for a second, but I was. All right, so let's go ahead and figure out what this is. All right, so we have 27.07 kilometers, but I'm not going to write that. I'm just going to leave it off. Squared plus the b squared, which is 7.07 kilometers squared equals c squared. Now, if you're wondering what my c squared is, it's this over here squared. All right, so we need to solve it for c. So all that we need to do is punch this into the calculator and take the square root of it. Okay, so let's do that. All right, time to bring up the calculator again. Sorry, this takes a little bit of time. We have 27.07 squared plus 7.07 squared. Enter. Now this is c squared. But remember, I do not need c squared. I need just c. So I'm going to take the square root of this. Now you can do this a couple of ways. You can go ahead and just say raise this to a half. That'll work. And that will be one of our answers. So we get 27.97802352. I'm just going to say that basically c is approximately, let me write it this way. My c is approximately, what was that, 28. It was roughly 28 kilometers. Now, that's this diagonal's length, 28. Now, that's great, but remember that a vector has magnitude and direction. I've got to get the direction. So let's find this angle right here. This is theta. All right, let's find it. Okay, theta is equal to the inverse tangent, okay, and it's going to be your short over your long. Some of you may prefer to say, I mean, that's the easiest way to say it with vectors. Some of you may say Oscar has a heap of apples, which is opposite over adjacent. That's fine. Whichever one you want to use is fine. The reason why it's short over long, though, is if you will always start out drawing the longest vector first, then the shortest, then you can always use short over long. So let's go ahead and plug in our short over long. So we get theta equals the inverse tangent of, what is our short side? Well, our short side was this 7.07 divided by the longest side, which is 27.07. All right, so let's enter that into our handy-dandy cheatalator. All right, so we have inverse tangent. You get that by hitting second tangent. Good. And then 7.07 divided by, now remember, make sure you're in degrees, 27.07. Make sure you also close those parentheses. All right, press enter. And then my degree measure is roughly 14.6. Now, the original problem gave 2 sig figs, so we should also use 2 sig figs. So our sig figs here would be theta equals 15. So our angle is approximately, that's what that wave equal sign is approximately 15 degrees. So I have my angle. It's going to be 15 degrees, but I'm not done with just writing 15 degrees. I also got to give a direction. Now, when you get ready to say a direction, like 28 kilometers, 15 degrees, it's always going to be announced short of long. So it's going to be north of east, because the short is the north. The long is the east. So that's going to be our final answer, which is 28 kilometers and 15 degrees north of east. Of course, I rounded this to 2 sig figs on each of those. So, guys and gals, I hope this was helpful. Just remember that when you're dealing with vectors, no matter what vector you're given, if they're asking you to add them, if they're asking you to subtract them, the first thing you want to do is calculate all of your x components and all your y components. It doesn't matter if it's going completely to the left, completely to the right. Go ahead and be safe and do cosine and sine on all those, and you'll be totally A-okay. Okay, so once again, make sure you just organize them in such a way as you draw them, you put them head to tail, and you'll get them right. Okay, just take your time, don't hurry, be patient. Okay, all right, guys, I hope it was helpful, and if you got any more questions, just message me and I'll help you out. All right, y'all have a great day.